Now we are going to see properties of inverse trigonometric functions. Properties of inverse trigonometric functions. Inverse trigonometric functions. Properties of inverse trigonometric functions. Let us take property 1. Property 1. We have seen sin inverse of x, cos inverse of x, tan inverse of x, cosecant inverse of x, secant inverse of x, and cot inverse of x. 6 inverse trigonometric functions. Now, what are the properties governing these functions? The first property says 1. Sin inverse of sin theta is equal to theta. But here we have to be careful. Theta belongs to square bracket minus pi by 2 to pi by 2. The second property says cos inverse of cos theta is also equal to theta. But here theta belongs to 0 to pi. 0 to pi. So you should recollect what is the domain and range of inverse trigonometric functions. If you see the table, then you will understand this. Tan inverse of tan theta is also equal to theta. Theta belongs to 0 to pi by 2. Fourth one is cosecant inverse of cosec theta is also equal to theta. So what is the theta here? Theta is same like this. Square bracket minus pi by 2 to pi by 2. But the theta not equal to 0. Because cosecant theta when 0 means 1 by sin theta, 1 by sin 0 is 0, 1 by 0. So it is not possible. So you have to be careful here. Then secant inverse of secant theta is also equal to theta. Now here theta belongs to, you can see for cos it is square bracket 0 to pi, but here theta should not be equal to pi by 2. Theta should not be equal to pi by 2. Next we have the last one. Cot inverse of cot theta is also equal to theta. Theta belongs to ordinary bracket 0 to pi. So these are very important conditions. So all these inverse trigonometric functions properties have conditions attached to them. Conditions. So let us try to prove this. Prove. If f from A to B is a bijection, then we know from the definition of inverse, this is definition of inverse function. So then f inverse from B to A exists such that f inverse of x is equal to, that is f of, so here we will take f inverse of f of x. So f inverse of f of x, this is f inverse of y, that is equal to x. F inverse of y is equal to x. Why f inverse of y is equal to x? You see this, y is equal to always f of x. What is x? If we transpose this f function to the left hand side, it becomes inverse function. So x is equal to f inverse of y. So based on this definition all this can be proved. All this can be proved. I will be proving now only one of this. Okay. First one. Sin inverse of sin theta is equal to theta. Let sin theta is equal to x, where theta belongs to square bracket minus pi by 2 to pi by 2. So once sin theta is theta belongs to minus pi by 2 to pi by 2, x will belong to minus 1 to 1, that is the range of sin inverse of x function, sin theta function. Then x belongs to square bracket minus 1 to 1. If theta belongs to square bracket minus pi by 2 to pi by 2, then x belongs to square bracket minus 1 to 1. Now we can transpose this. What is the transpose of this? You see, theta is equal to sin inverse of x. Theta is equal to sin inverse of x. Now this is theta is equal to sin inverse of, what is the x we have taken? Sin theta. So this implies sin inverse of sin theta is equal to theta when theta belongs to minus pi by 2 to plus pi by 2. Similarly, other results can be proved. Similarly, we can prove the other results. Okay. Again, take it. Sin inverse of sin theta is equal to theta. Cos inverse of cos theta is also equal to theta. Tan inverse of tan theta is theta, but theta belongs to 0 to pi by 2. So, try to remember the first property. This will be used in problems. Okay. Okay. Now we will start looking at the property 2 of the inverse trigonometric functions. Property 2. First one, sin inverse of x is equal to x. Here x belongs to square bracket minus 1 comma 1. Second one, cos inverse of x is also equal to x. Here also x belongs to minus 1 comma 1. Third one is tan inverse of x is equal to x. X belongs to real number. So any real number it will take tan inverse of x. Fourth, cosecant inverse of x is also x. Here, what is the x value for cosecant domain of cosecant inverse of x? Cosecant inverse of x domain. It is x belongs to minus infinity to minus 1 union 1 to infinity, or we are writing x is r minus 1. All are same, both are same. Only different ways we are writing it. R minus set of real numbers minus bracket minus 1 comma 1. So secant inverse of x is equal to x. X belongs to r. Okay, we write only one. Okay, either of this we can write. Sixth one is cot inverse of x is also equal to x. X belongs to r, real number. Any real number x can take. So another property 2, which is sin inverse of x is equal to x. First property is sin inverse of sin theta is equal to x. First property is that. Now let us take proof. Proof of this. Same f is from A to B is a bijection. Then f inverse from B to A exists such that f inverse of y is equal to f bracket f inverse of y. What is f inverse of y? Just we did it in the previous property. You see, f inverse of y is x, that is y. So this is the definition of inverse functions. From that we are going to take the proof. Let theta is equal to sin inverse of x. Theta is equal to sin inverse of x. Where x belongs to -1 to 1 and theta belongs to what? When x is -1, it is -5/2. And what is when x is 1? It is 5/2. So when this happens, we can get inverse functions. That is, we can transpose. When you transpose sine to this side, you get sin theta is equal to x. What is theta we have taken now? Theta is equal to sin inverse of x. So sin inverse of x is equal to x. X belongs to square bracket -1 comma 1. So similarly we can prove the other results. The other results also same. Other results, but both the results are different. Property 1 is different from property 2. Property 1 says sin inverse of sin theta is equal to theta. Property 2 says sin inverse of x is equal to x. We should not get confused. Both are different properties. Okay. So property 3 of inverse trigonometric functions. Property 3 of inverse trigonometric functions. First one is sin inverse of -x is equal to minus sin inverse of x. Here x belongs to -1 to 1. Sin inverse of -x is equal to minus sin inverse of x. Cos inverse of -x is equal to phi minus cos inverse of x. X belongs to -1 to 1. Then third one, tan inverse of -x is equal to minus tan inverse of x. X belongs to R. Fourth one, cosecant inverse of minus x is equal to minus cosecant inverse of x. See, mod x greater than or equal to 1 or minus comma 1, minus 1 comma 1. See, these are the symbols used. Mod x is greater than or equal to 1 is the domain for cosecant x. Okay. This is the secant inverse of minus x is equal to minus secant inverse of x or minus 1. X belongs to last one is this is the phi minus secant inverse of x you have to take, and then here cot inverse of minus x is also phi minus cot inverse of x. X belongs to R. X belongs to R. So now we have to prove this. So listen carefully how we are proving this first property. Sin inverse of minus x is equal to minus sin inverse of x x belongs to minus 1 comma 1. So when x belongs to minus 1 comma 1, minus x also belongs to minus 1 comma 1. How? See, when x is minus 1, what is minus x? It is plus 1. When x is 1, what is minus x? Minus 1. So minus x also belongs to minus 1 comma 1. So this is very important. Now we will learn this. Now we can take sine inverse of minus x is equal to theta. Sine inverse of minus x is equal to theta. Here already I have written, minus x belongs to minus 1 comma 1. Theta belongs to what? Minus pi by 2 to pi by 2. Now this is a bijective function. This function is a bijective function. Now we can transpose. If it is not a bijective function, we cannot transpose it. We cannot do the transpose work. Now I will transpose this. Minus x is equal to sin theta. Sin inverse, when it goes to the other side, it becomes sin theta. Now you take, this is x is equal to minus sin theta. X is equal to minus sin theta. Is it correct? Now we need sin inverse of minus x. What is theta here? We have taken theta as sin inverse of minus x. So how will you do this? See, from here, x is equal to minus x is equal to sin theta. Now, how to write this? Trigonometry you should know. That is sin of minus theta. So, minus sin of minus theta is what? Sin inverse of x. So, minus sin you take it to this side. Minus sin inverse of x is equal to theta. Theta is sin inverse of minus x. So this is the proof. Sin inverse of minus x is equal to minus sin inverse of x. This is the proof for this property, which is cos inverse of minus x is equal to phi minus cos inverse of x. X belongs to minus 1 to 1. Now, let theta is equal to cos inverse of minus x. Already we know that minus x belongs to minus 1 comma 1 and theta belongs to, here it is 0 to pi. Theta belongs to cos inverse domain, that is 0 to pi. Now transpose this, you will get cos theta is equal to minus x, or x is equal to minus cos theta. Minus cos theta is cos of pi minus theta. It is not minus cos of minus theta also. It is cos of pi minus theta we have to take. It is not cos of minus theta. It is cos of pi minus theta is equal to minus cos theta. Now, x belongs to minus 1 to 1 and pi minus theta belongs to 0 to pi. Pi minus theta belongs to 0 to pi because theta belongs to 0 to pi. Suppose if you put theta is equal to 0, you will get pi. When you put theta is equal to pi, you will get 0. Therefore, pi minus theta varies between 0 to pi. Now, you can transpose this. That is cos inverse of x is equal to pi minus theta, or theta is equal to pi minus cos inverse of x. What is theta that we have taken? Cos inverse of minus x. Cos inverse of minus x is equal to pi minus cos inverse of x. Very, very important. Okay? Cos inverse of minus x is equal to pi minus cos inverse of x. Other core properties, similarly you have to prove. Similarly, we have to prove sin inverse of minus x is equal to minus sin x, cos inverse of minus x is equal to pi minus cos inverse of x. Same way we have to prove other 4 trigonometric functions. Okay. Now we are going to see property 4 of inverse trigonometric functions. Property 4. Sin inverse of 1 by x is equal to cosecant inverse of x. You see the reciprocal nature of this sin function and cosecant function. Here the numbers are also getting reciprocated. So x belongs to ordinary bracket union 1 to infinity. X belongs to. Then cos inverse of 1 by x is equal to secant inverse of x. X belongs to minus infinity to minus 1 and 1 to infinity. Then tan inverse of 1 by x is equal to cot inverse of x. X belongs to R. So this is the property. See, this property will be used in many problems. When we are solving problems, we will be taking sin inverse of 1 by x is equal to cosecant inverse of x, or cosecant inverse of 1 by x is equal to sin inverse of x. Both are applicable, both properties, both ways we can take it. Now we will see the proof for this. Proof 1. Sin inverse of 1 by x is equal to cosecant inverse of x. Cosecant inverse of x. Now let cosecant inverse of x is equal to theta. X is equal to cosec theta. X is equal to cosec theta. Now what is this? 1 by x is equal to sin theta. This is cosecant theta. If you want sin theta, we have to take reciprocals. Okay. Now theta becomes sin inverse of 1 by x. So this is first equation. This is second equation. From 1 and 2. From 1 and 2. Sin inverse of 1 by x is equal to cosecant inverse of x. Sin inverse of 1 by x is equal to cosecant inverse of x. Similarly, we can prove cos inverse of 1 by x is equal to secant inverse of x. So here take let the secant inverse of x is equal to theta. Now it becomes secant theta is equal to x. Now this becomes cos theta is equal to x. Cos theta is equal to 1 by x. So theta is equal to cos inverse of 1 by x. Take this as 1 and 2. From 1 and 2, cos inverse of 1 by x is equal to secant inverse of x. Similarly, prove, you yourself can prove that tan inverse of 1 by x is equal to cot inverse of x. Cot inverse of x. We are going to see property before we just saw that is reciprocal functions property. Sin inverse of 1 by x is equal to cosecant inverse of x, etc. Now, fifth property is very important property. Property 5. First one is sin inverse of x plus cos inverse of x is equal to pi by 2. X belongs to square bracket minus 1 comma 1. So same thing we can tell like this also. Mod x less than or equal to 1. This is also correct. Mod x is less than or equal to 1. Next, cosecant inverse of x plus secant inverse of x is also pi by 2. Here, x belongs to r minus 1 comma 1. Or mod x is greater than or equal to 1. Mod x is greater than or equal to 1. Next, we have the third property. Tan inverse of x plus cot inverse of x is equal to pi by 2. Here x is any real number. X belongs to R. So this property frequently we use in problems. And also 2 marks question they ask you to prove this. 2 mark questions they ask you to prove. So you will do the proof now. Proof. First one, sin inverse of x plus cos inverse of x is equal to pi by 2. Let theta is equal to sin inverse of x. Since x belongs to square bracket minus 1 comma 1, theta will belong to minus pi by 2 to pi by 2. This is a bijective function. So we can take the inverses, that is transpose this. Sin theta is equal to x. So sin theta is equal to x. Now we can take sin theta can be written as cos of pi by 2 minus theta, this is equal to x. Now transpose this. Pi by 2 minus theta is equal to cos inverse of x. Then pi by 2 minus theta is sin inverse of x. Therefore, sin inverse of x plus cos inverse of x is equal to pi by 2 mod x is less than 1. So take this to the side. You will get the sin inverse of x plus cos inverse of x. Similarly, we can prove the property cosecant inverse of x plus secant inverse of x is equal to pi by 2. Very, very important property. Cosecant inverse of x plus secant inverse of x is equal to pi by 2. Mod x greater than or equal to 1. Now, let cosecant inverse of x is equal to theta. When this becomes, let us transpose this. How will you transpose this? This x is equal to cosec theta. X is equal to cosec theta. Cosec theta we can write it as secant of pi by 2 minus theta. Now, again, transpose this. Secant inverse of x is equal to pi by 2 minus theta. Secant inverse of x is equal to pi by 2 minus cosecant inverse of x, because theta we have assumed it as pi by 2 minus x. Now, the last answer, cosecant inverse of x plus secant inverse of x is equal to pi by 2. So, this is the proof of this, the second one. Similarly, we can prove the third one also. Tan inverse of x plus cot inverse of x is equal to pi by 2. R. Tan inverse of x plus cot inverse of x is equal to pi by 2. X belongs to R, real number. How to do this? Let theta is equal to tan inverse of x. So tan theta is equal to x. Tan theta can be written as cot of pi by 2 minus theta. So pi by 2 minus theta is equal to cot inverse of x. Pi by 2 minus tan inverse of x is equal to cot inverse of x. Now we can take tan inverse of x plus cot inverse of x is equal to pi by 2. X belongs to the real number. Now this is the fifth property. We have got another two properties. They are also used in frequently in problems. So we should learn this. Property 6. 1. Tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y divided by 1 minus xy. So, addition property, tan inverse of x, two inverse trigonometric functions, we are adding it. Sin tan inverse of x plus tan inverse of y is tan inverse of x plus y divided by 1 minus xy. The second one is same, but minus sign. Tan inverse of x minus tan inverse of y. Now you take this as formula tan inverse of x minus y by 1 plus xy. Now we can prove this. Proof 1. Take tan inverse of x is equal to angle A. Tan inverse of y is equal to angle B. So every inverse trigonometric functions they indicate an angle. So it should come to your mind that they are angles. Tan inverse of x, tan inverse of y. Now this implies tan A is equal to x, tan B is equal to y. Tan A is equal to x and tan B is equal to y. Now, what is formula tan of A plus B? Transformation, that is compound angle formula tan A plus tan B divided by 1 minus tan A into tan B. Tan A plus tan B. So, let us substitute all these things. Tan of A plus B is equal to x plus y divided by 1 minus xy. What is A plus B? Tan inverse of x plus y divided by 1 minus xy. So this is the proof for this. Now what is A we have taken? Tan inverse of x. B is tan inverse of y. Total you get tan inverse of x plus y divided by 1 minus x. So here for this property there are a lot of conditions that we will take up when we are going for entrance examinations. We will tell you different conditions are there for this. We can do the same way. We can do this. Tan inverse of x minus tan inverse of y is equal to tan inverse of x minus y by 1 plus xy. Further, you have to take tan of a minus b. Take tan of a minus b. So, this completes almost all the properties. We will do one more property here. We will see that, how to prove that. So, that is also very important properties. Okay. Now, property 7. 6 properties we have done. Now, property 7. Property 7, you see 2 tan inverse of x is equal to Sin inverse of 2x by 1 plus x square. 2 tan inverse of x is equal to cos inverse of 1 minus x square by 1 plus x square. 1, 2, 3. 2 tan inverse of x is equal to tan inverse of 2x by 1 minus x square. For this, mod x less than or equal to 1, here x greater than or equal to 0, and here x is between minus 1 and 1. See, only under these conditions, these properties are valid. For other conditions, the properties changes, but that is not covered in our text. Okay, for entrance examination, we will cover all those things, but not here. Proof of this. Let tan inverse of x is equal to y. Tan inverse of x is equal to y. X is equal to tan y. X is equal to tan y. Now let us take RHS in the first one. RHS is equal to sin inverse of 2x by 1 plus x square. This is the sin inverse of 2 tan y divided by 1 plus tan square y. So, this is nothing but sin inverse of sin 2y formula. Sin 2y is equal to 2 tan y divided by 1 plus tan square y. Therefore, this is equal to 2y. 2y means y is tan inverse of x. So, this is RHS. So, this is the proof. All the other things also we have to take appropriate substitution. What substitution we have taken? X is equal to tan y. So, for second property also we can prove like that only. Take tan inverse of x is equal to y. Tan inverse of x is equal to y. This implies x is equal to tan y. This implies x is equal to tan y. Okay. Now let us start RHS. RHS here is cos inverse of 1 minus x square by 1 plus x square. Substitute x is equal to tan y. That is 1 minus tan square y by 1 plus tan square y. Substitute x is equal to tan y. This in identities of trigonometry, we have got cos 2y formula. Cos 2y is equal to 1 minus tan square y by 1 plus tan square y. So this is equal to 2y. 2y, y is tan inverse of x. That is equal to RHS and LHS. This is equal to LHS. That is equal to LHS. So RHS I have taken and then we have proved it to LHS. Even LHS you can take it and prove it to RHS. Now third one is also similar. All the things the same substitution, same methods. Okay, let tan inverse of x is equal to y. Tan inverse of x is equal to y. Then x is equal to tan y. Now take the RHS in the third property, that is 2 tan inverse of x is equal to tan inverse of 2x by 1 minus x square. Tan inverse of 2x by 1 minus x square. So this is tan inverse of 2 tan y divided by 1 minus tan square y. So this is tan inverse of tan 2y. Using the first property here, tan inverse and tan cancels. First property, sin inverse of sin theta is equal to theta. That property we are applying here. 2y will get 2 tan inverse of x. This is LHS. So almost all the properties we have completed. Now let us go to the problems. Okay. Now we will see the problems in inverse trigonometric functions. Once we complete all the problems, this inverse trigonometric function chapter is also over for you. You have to practice for the test. Now first question is example 1. In that first one, sin inverse of x in 2x into root of 1 minus x square is equal to 2 sin inverse of x. Here x is greater than or equal to minus 1 by root 2, less than or equal to 1 by root 2. Second question is again sin inverse of 2x into root of 1 minus x square, that is 2 cos inverse of x. X greater than or equal to 1 by root 2, less than or equal to 1. Okay, this is also suitable substitutions we have to take. See here, in the first question, we can take x is equal to sin theta. This implies theta is equal to sin inverse of x. Now, what is LHS? LHS is sin inverse of 2x into root of 1 minus x square. Now, in this, let us put x is equal to sin theta. X is equal to sin theta, we are putting 2 sin theta into square root of 1 minus cos square theta. So this is sin inverse of 2 sin theta. What is 1 minus cos square theta? It is 1 minus sin square theta. 1 minus sin square theta is cos square theta. Root of cos square theta. Root of cos square theta is cos theta here. Okay. Now this is sin inverse of 2 sin theta cos theta. What is that? What is the identity? Multiplying formulas. Sin 2 theta, 2 sin theta cos theta is. So sin inverse of sin theta is equal to theta. So this is 2 into sin inverse of x. So now we have taken LHS is equal to RHS. So similarly, you can do for the second one, but here you can see here it is cos is there. So take second one, let x is equal to cos theta. This implies theta is equal to cos inverse of x. X is equal to cos theta, theta is equal to cos inverse of x. Now you can complete this. LHS is equal to sin inverse of 2x into root of 1 minus x square. Put x is equal to cos theta in this. That is 2 into cos theta into root of 1 minus cos square theta. So this is sin inverse of 2 cos theta into square root of 1 minus cos square theta is sin theta, because 1 minus cos square theta is sin square theta. Therefore, root of sin square theta is sin theta. Now you take this sin inverse of sin 2 theta. That is 2 theta. Now what is theta here? Cos inverse of x. This is RHS. So this is how we have to start doing the problems. What we are doing, substitutions. First method, model problems are substitute. Suitable trigonometric functions, you should take it as a substitution for x. then we will be able to arrive at the answers. Now, example 2. So that tan inverse of 1 by 2 plus tan inverse of 2 by 11 is equal to tan inverse of 3 by 4. So here what formula? Property 6. What is that says? I write for you the property tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y divided by 1 minus xy. 1 minus xy. Now x is equal to 1 by 2, y is equal to 2 by 11. So now let us do this. This is tan inverse of 1 by 2 plus tan inverse of 2 by 11 is equal to tan inverse of 1 by 2 plus 2 by 11 divided by 1 minus 1 by 2 into 2 by 11. Okay. Now this is equal to tan inverse of LCM you take. This is 11 plus 4. Next here 22 minus 2 divided by 22. So this is tan inverse. Now simplify this. 22 cancels. 15 by 20, that is equal to tan inverse of 3 by 4. So that is our answers. Prove that problem. Show that problem. So what formula that we have used? Tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y divided by 1 minus xy. So if you use that and appropriately take your x and y, you will get the answer. Now let us go to the next problem. So we have seen the second model problem. First model is substitution. Second model we are applying the property. So just applying the property. You should know the property like that. Like that you will be seeing around 10 or 12 problems we will see in the second model. First model we will see some 7 to 8 problems. Then the most important is express what we are going to see. Third model problem. Example 3. Express tan inverse of cos x by 1 minus sin x. X is greater than minus 3 pi by 2 less than 3 pi by 2 in the simplest form. In the simplest form. So almost 20 problems are there in this method. Around 20 problems are there in this model. Okay. Now let us see how to simplify. We should know trigonometry for simplification. For simplification we should know the trigonometry. So then if we will be able to simplify this. See, the trick is this cos x by 1 minus sin x, we should convert it into tan. Then we can apply the first property of inverse trigonometric functions and simplify it. So you will get simplest form. What is the trick here? Here tan inverse is there. This should be converted. Cos x by 1 minus sin x should be converted to tan function. How to do this? Let us see. Tan inverse of cos x divided by 1 minus sin x. So now I am going to do cos x. I am going to write it as sin of pi by 2 minus x. This I am going to write it as cos x, sin x in the denominator, y. See, sin by cos becomes tan. So we can get tan here. Let us see whether we are getting it. This is sin theta is equal to, I write the formula 2 sin theta by 2 cos theta by 2 and 1 minus cos theta is equal to 2 sin square theta by 2. So if you have forgotten the formulas, I am writing it for you. Sin theta is 2 sin theta. Here theta is pi by 2 minus x. Therefore, if you divide this by 2, pi by 4 minus x by 2 cos of 2 sin pi by 4 minus x by 2 cos of pi by 4 minus x by 2 divided by 2 sin square pi by 4 minus x by 2. Okay. Now 1 sin pi by 4 minus x by 2, 2 cancels. Now you will get tan inverse of cot of pi by 4 minus x by 2. Then again we are not very close. Okay. Tan inverse the cot function is there. How to convert the cot function into tan function? How to convert the cot? Cot theta is equal to tan of pi by 2 minus theta. Cot theta. So trigonometry I am recollecting it. I am telling you again how to do the trigonometry. That is cot theta is tan of pi by 2 minus theta. Now I am writing it pi by 2 minus pi by 4 minus pi by 2. Okay. Now what is the simplification there? Tan inverse of pi by 2 minus pi by 4. We get pi by 4 minus of minus pi by 2 x by 2. Sorry, here it is not pi by 2, it is x by 2. So pi by 4 tan inverse of tan of pi by 4 plus x by 2. So tan inverse of tan theta is theta. That was the first property that we studied in the inverse trigonometric functions. Tan inverse of tan theta is equal to theta. So what is the simplified form? Pi by 4 plus x by 2. Pi by 4 plus x by 2. So that the simplified forms 3 marks questions. So regularly they ask in inverse trigonometric functions 1 mark question and 1 2 mark questions and 2 2 marks questions. 4 marks they will give, 4 plus 1 5, and then 1 3 mark question will be there. So 8 marks will be there in inverse trigonometric functions. In your examination 8 marks will be there for this. So again let us see the next question. Again simplest form. Write cot inverse of 1 by square root of x square minus 1 x greater than 1 in the simplest form. Write cot inverse of 1 by square root of x square minus 1 in the simplest form. So here substitutions you should think substitutions in such a way that this becomes a cot function. This becomes a cot function. If this becomes cot function, this should become tan function. 1 by tan is cot. 1 by tan is cot. Therefore, we should make this, what substitution you can take here? X is equal to secant theta. This implies theta is equal to secant inverse of x. Now cot inverse of 1 divided by square root of. Okay, what is the formula? 1 plus tan square theta is equal to secant square theta. Secant square theta minus 1 is equal to tan square theta. First identity is in the trigonometric class, the first identity. That is, so we don't know that. That is the problem. Okay. So this is 1 by square root of tan square theta. So cot inverse of 1 by tan theta. So cot inverse of cot theta, that is equal to theta. What is theta now? Secant inverse of x. So simplest form is, so this is equal to secant inverse of x. Secant inverse of x. Now we are doing example problems. Shortly we will go to the exercise problems. Next question I will write. Prove that tan inverse of x plus tan inverse of 2x is equal to tan inverse of 3x by 3x minus x cube by 1 minus 3x square. Mod x is less than 1 by root 3. Mod x is less than 1 by root 3. Now, see, this is the model. I told you second model. Tan inverse of x plus tan inverse of y formula. Once you apply that, you can simplify that and prove it. Okay. Now, LHS is tan inverse of x plus tan inverse of 2x. Tan inverse of x plus tan inverse of y. So, how will you do this? Tan inverse of x plus tan inverse of y. So, 2 tan inverse of x I think. So, I will change it. Tan inverse of the problem is 2x by 1 minus x square. Okay. 2x by 1 minus x square. Now, x 2x by 1 minus x square divided by 1 minus x into 2x by 1 minus x square. Okay, listen to this. So, tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y divided by 1 minus x into y. Formula I have written already in one of the problems. Refer that. Now, simplify this. Tan inverse of 1 minus x square x into 1 minus x square plus 2x divided by 1 minus x square minus 2 x square divided by 1 minus x square. Now, in all these problems, the denominator will get cancelled. So, 1 minus x square cancels. Now, simplify the numerator and the denominator here. X minus x cube plus 2x divided by 1 minus 3x square. So, this is equal to tan inverse of 3x minus x cube divided by 1 minus 3x square. That is just. So, prove that problem. Here we have applied what? We have applied the property 6, tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y divided by 1 minus x square. I will do one more problem now. That is a simple one. Find the value of cos of secant inverse of x plus cosecant inverse of x mod x greater than or equal to 1. Mod x is greater than or equal to 1. See here, you should understand property 5. Today I did it. Again, if you see the property 5, we have done already. What is the property 5 says? Secant inverse of x plus cosecant inverse of x is equal to pi by 2. So directly apply the property. This is cos pi pi by 2. What is cos pi by 2? 0. Property 5. Refer property 5. Property 5. Inverse trigonometric functions. Property 5. If you refer, you will get. Now all the worked out examples are over. Now let us go to the exercise. Okay, I am going to start now exercise. That is exercise 2. The exercise 2.2. First question is prove the following. Prove the following. 3 sin inverse of x is equal to sin inverse of 3x minus 4x cube. X belongs to minus 1 by 2 to 1 by 2. X belongs to minus 1 by 2 to 1 by 2. Now we have started the exercise questions. Now what is substitution we have to see? Yes, see from here you will get the idea. Substitution. Let x is equal to sin theta. Then theta is equal to sin inverse of x. Now let us take RHS. This is the sin inverse of 3x minus 4x cube. Sin inverse of 3 sin theta minus 4 sin cube theta. What is 3 sin theta minus 4 sin cube theta in trigonometry? Its value is, that is sin 3 theta. So sin inverse of sin 3 theta, 3 theta. Theta is sin inverse of x. So this is equal to LHS. So RHS is equal to LHS. We have proved. The first question is over. First question in the exercise is over. Now let us go to the second question. So we have taken substitution. X is equal to sin theta for that. Now we can tell what substitutions we have to take for this question. 3 cos inverse of x is equal to cos inverse of 4x cube minus 3x. X belongs to 1 by 2 to 1. X belongs to 1 by 2 to 1. What substitution we have to take? We can easily think, because cos inverse of x we have to get. So take, let x is equal to cos theta. Then theta is equal to cos inverse of x. Theta is equal to cos inverse of x. Now take the RHS and prove it is equal to LHS. Prove that it is equal to LHS 4 into x cube minus 3x. Now I am going to substitute for x cos theta. Now 4 cos cube theta minus 3 cos theta. In trigonometry, this is cos 3 theta identity. Cos 3 theta is equal to 4 cos cube theta minus 3 cos theta. So by property 1 of inverse trigonometric functions, cos inverse of cos theta, cos 3 theta is equal to 3 theta. That is 3 cos inverse of x. That is LHS. So 2 problems. All the problems takes only 2 minutes only it takes. Okay, you should learn it. And you will get 2 marks for this question. This is the first model, the substitution. We have to take substitutions. Now the second model problem, I start this. Second model problem. Tan inverse of 2 by 11 plus tan inverse of 7 by 24 is equal to tan inverse of 1 by 2. Okay, this we have already done 2 problems in this model. in the workout example. What is the model here? Tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y divided by 1 minus xy. So let us apply this. LHS is equal to tan inverse of 2 by 11 plus tan inverse of 7 by 24. Okay, let me apply the property now. By property, what we are getting? Tan inverse of 2 by 11 plus 7 by 24 divided by 1 minus 2 by 11 into 7 by 24. Okay, what is the LCM here? This is 24 into 11. So this is 48 plus 77 divided by. What is 24 into 11? 264 minus 14 divided by 24 into 11. Denominator. So this cancels. Tan inverse of 5, 1, 2, 5, 8 plus 4, 12. This is a 250. So this is a tan inverse of 1 by 2. It is RHS. Okay, this is a simple problem. I told you now there will be around 10 problems in both the miscellaneous exercise and this exercise involving this model. And the first model, substitution model, already we have done 4 problems in substitution model and a simplified form. In that you will get around 20 problems. Okay, these are the models. Other problems will be miscellaneous type. Okay. Now, fourth question, let us see. 2 tan inverse of 1 by 2. 2 tan inverse of 1 by 2 plus tan inverse of 1 by 7 is equal to tan inverse of 31 by 17. 31 by 17. See, we have got the formula tan inverse of x. We don't have the formula for 2 tan inverse of x, but 2 tan inverse of x we have the formula. Go and see the property number 7. I will write it. What is 2 tan inverse of x? Tan inverse of 2x by 1 minus x square. 2 tan inverse of x is equal to tan inverse of 2x by 1 minus x square. Now let me apply this here. Tan inverse of 2 into 1 by 2 divided by 1 minus 1 by 4 plus tan inverse of 1 by 7. Now let us simplify that. This is equal to tan inverse of 1 divided by 3 by 4 plus tan inverse of 1 by 7. So this is the tan inverse of 4 by 3 plus tan inverse of 1 by 7. Tan inverse of 4 by 3 plus tan inverse of 1 by 7. Now this is apply tan inverse of x plus tan inverse of y formula. Tan inverse of x plus y 1 minus x into y. Tan inverse of x plus y divided by 1 minus xy. So this problem is important. You have 2 tan inverse of x. 2 tan inverse of x, there is a property there. 2 tan inverse of x, you can convert it into tan inverse of 2x by 1 minus x square. Use that there. Now the last step, only simplifications. Tan inverse of 21 LCM 28 plus 3 divided by 21 minus 4 divided by 21. So this is equal to tan inverse of 31 by 17. That is RHS 31 by 17. Okay, now let us go to the next type of problems. Okay, now we are continuing with the exercise problems. Simplest form, that is the third model. See here, 2 problems in the first model, second model also 2 problems we did, third model we are doing. Simplest form. Write that simplest form of the following function. Of the following functions. Fifth question is tan inverse of root of 1 plus x square minus 1 divided by x. X not equal to 0. Only that they have given. X not equal to 0. So tan inverse of 1 plus x square by minus 1. So here what we have to do? See, the substitutions will always get the rule for substitution. Substitution, these are the rules. 1 minus x square, take x is equal to sin theta or cos theta. X square minus 1, x is equal to secant theta to secant theta. 1 plus x square, take x is equal to tan theta or theta. So, this is applicable in differentiation, also in integration. So, these are the substitutions. There are more rules are there for substitution, but this is enough. Whenever it comes, I will always tell you what are the substitutions to be taken. See, for example, 1 minus x by 1 plus x. What is the substitution we have to take? X is equal to tan theta we have to take. Now, put x is equal to tan theta. This means theta is equal to tan inverse of x. Now let us take this tan inverse of square root of 1 plus tan square theta minus 1 divided by tan theta. X is tan theta. X is tan theta we have substituted. So what is root of 1 plus tan square theta? Do you know that? This is secant theta minus 1 divided by tan theta. This is tan inverse of 1 by cos theta minus 1 divided by sin theta by cos theta. So this is tan inverse of 1 minus cos theta divided by sin theta by cos theta. So any doubts? Only root of 1 plus tan square theta. That is secant theta. Secant theta is 1 by cos theta. Simplified. Now tan inverse of 1 minus cos theta by sin theta. What is 1 minus cos theta? I have already written in one of the problems. What is 1 minus cos theta formula? 2 sin square theta by 2. What is sin theta? 2 sin theta by 2 cos theta by 2. Why we are doing this? Here tan inverse is there, but here this function we have to convert it into tan function, not cot or sine or cosine. We need tan function there. For that purpose we are taking 1 minus cos theta is equal to 2 sin square theta by 2. Sin theta is equal to 2 sin theta by 2 cos theta by 2. Cancel this. You can cancel 1 of the sin theta. Now you take tan inverse of tan theta by 2. Tan inverse of tan theta is theta. Now this is 1 by 2. Theta is tan inverse of x. So simplified form of that is 1 by 2 tan inverse of x. So simplified format, we have done 3 problems now. We have worked out examples 2 and then this one. Let us go to the next question. Tan inverse of 1 by square root of x square minus 1 mod x greater than 1. Mod x is greater than 1. Now let us take. Already we have done one problem. This should become tan. That means root of x square minus 1 becomes cot. So what we have to take? You know the formula? X is equal to cosecant theta. This is theta is equal to cosecant inverse of x. Now let us apply this. Tan inverse of 1 by square root of cosecant square theta minus 1. This is 1 by cot square theta. See, cot square theta plus 1 is equal to cosecant square theta. Trigonometric identity. Cot square theta plus 1 is equal to cosecant square theta. Therefore, tan inverse of 1 by cot theta. That is tan inverse of tan theta, which is equal to theta. Theta is equal to cosecant inverse of x. So another simplified formula work that we have completed. Now let us go to the next one. 7th question. Tan inverse of square root of 1 minus cos x by 1 plus cos x. X is between 0 to pi. X is between 0 to pi. Okay. Here, directly you can simplify. What are the formulas? This is 2 sin square x by 2. This is 2 cos square x by 2. So 1 plus cos x is 2 cos square x by 2 formula. 1 minus cos x is already we have done here also. 1 minus cos theta we have done. 2 sin square theta by 2. Same thing I have written. So tan inverse of square root of tan square x by 2. Tan inverse of tan x by 2, which is equal to x by 2. That is x by 2.